Let me tell you about this Prague project, a local gym with loyal customers, but their app, ancient. It held back their business, preventing growth. We were asked to rebuild it, make it modern. Things were going smoothly until we hit a major roadblock, the workout selection screen. The problem? A single clunky drop-down list, hard to use, impossible to scale. The demo was just 2 weeks away. 2 weeks. We had to get this screen right, fast. We needed something clean, simple, and efficient. Someone suggested a multi-choice widget. Everything visible. User could just tap their workouts. Tap, tap, done. No endless scrolling, no more guessing. Clear options, quick selection. It felt like the right solution. Simple, fast, easy. But with that 2-week deadline, the pressure was on. But we had a plan. Let's see how we made it happen. And hey, stick around. This multi-select solution, it's super versatile and you can use it in your own Flutter projects. We will start with creating a Flutter project. Fire up your favorite IDE. I use IntelliJ. Make a new Flutter project. Choose a good name. Keep it clean. We will focus on Android and iOS here. Then just hit create. Done. Now you see the default counter app code. We are gonna delete most of that. Now let's make the actual page where our workout selector will live. We need a new Dart file for this. I'll call mine workout selection page.dart. Inside this new file, it's time for our screen's main widget. Let's make it a stateful widget and name it workout selection page. And remember that standard material.dart import right at the top. Always need that one. Okay, basic widget shell is ready. Let's build the visual structure for the screen now. Inside the build method, we usually start with a scaffold. Think of the scaffold as the main container, the basic frame for the whole page. It gives us common UI elements like an app bar. Let's add that familiar bar across the top. And for its title, we will just put simple text, workout selection. Easy enough? Good. Now the scaffold also needs a body. That's where the main content goes. What goes in the body? Well, eventually our cool multi-choice widget will be here. But for right now, we will just put in a quick placeholder to make sure everything's hooked up. We will simply center some basic text. Yeah, and let's use the classic hello world. Can't go wrong with that. Perfect. That gives our basic page structure laid out. A solid starting point. Now let's actually hook this new page up so we can see it run. We need to jump back to our main.dart file for a second. Find where the home property is set in our material app. Let's replace my home page with our new workout selection page. Of course, you will need to import the file. Okay, code changed, import added. Let's hit hot reload. And there we go. We should see our hello world text right in the center of the screen. Nice. That confirms our basic page is wired up correctly. And one last thing for this setup. Let's turn off that debug show checked mode banner. Nobody likes that little banner in the corner, right? Okay, let's get to the core, building our multi-choice widget. Now Flutter has ChoiceChip. It's useful sometimes. But for the specific design and behavior we wanted for the gym app, it didn't quite fit the design. So we decided to build our own custom chip widget. Gives us more control. First step, let's create a new file just for this widget. We will call it choicechipwidget.dart. Inside this file, we will start simple with a stateless widget. Let's name it ChoiceChip widget. Now, what does a custom chip need to function? Well, visually it needs an icon and a title to show the workout type. It also needs to know whether it's currently selected or not, so it can change its appearance. That's usually a true-false flag. And finally, super important, we need something to happen when the user taps it. So it needs an onSelected callback function. First big thing, our chip needs to look different if it's selected, right? Active versus an inactive state. So let's set up some colors that change based on the boolean flag that we pass. We will define 4 variables: background color, content color, border color, and shadow color. Each will hold 2 distinct color values, one for the selected state and one for the unselected state. Okay, colors sorted. Now for the chip body itself, we want it to be tappable. Inkwell is perfect for this. It makes any widget tappable and gives that nice ripple effect feedback. We will wrap our whole chip design in an inkwell. And its onTap property? We just connect it directly to the onTap function passed into our widget. Simple. Inside the inkwell, the actual visual shape is going to be a container. Containers are great for controlling padding, background, borders, shapes, all that jazz. Let's add some padding using edge insets dot only. Keeps the icon and text from hitting the edges. Now let's style that container using box decoration. This is where the looks come together. We set the color using that background color variable we made, so it changes based on selection. Let's give it nice rounded corners using border radius dot circular 24. Looks way better. We will also add a border using border.all. Set its color to our border color variable and maybe give it the width of 1.5. Makes it look distinct. And you know what else would be cool? A little shadow when it's selected. Makes it pop off the screen slightly. It's easy to add. Still inside box decoration, we can add a box shadow. Okay, the container itself looks sharp. What goes inside it? The icon and the text. We want them side by side, so a row widget is the way to go. We will set its main axis size to main axis size.min, so the row just hugs its content, doesn't stretch across. First item in the row, the icon. We will use the image.asset widget and feed it in the icon path string that was passed into our widget. Let's make it a decent size, maybe width and height of 30. And a pro tip, always add an error builder. If the image path is wrong or the file is missing, it shows a fallback image not found icon instead of crashing. Need a little breathing room between the icon and the text next to it? A simple sized box with a small width, like 6, does the job perfectly. And the final piece, the workout text itself. Just a standard text widget here, using the text string passed into our widget. Let's style it a bit. We will set the color using our dynamic content color variable and make the font slightly bolder, maybe W500. Makes it clear and readable. That's it. Our custom ChoiceChip widget UI is built. But now the important part. Let's actually use it in our workout selection page. First though, remember our widgets need an icon path. We need some actual icon image files in our project. Let's quickly add them. Usually, you create an assets folder at the root of your Flutter project. Maybe make an icons folder inside that too, just to keep things tidy. Then copy your icon images in there. Now really, important step. You have to tell Flutter about this new assets folder. Open up your pubspec.yaml file, find Flutter section. You will see a commented out assets section. Uncomment that line and list your assets folder path below like assets/icons. Make sure the indentation is correct. YAML is picky. Okay, pubspec updated. Now because we have added assets and changed pubspec.yaml, a simple hot reload won't cut it. Flutter needs a hot restart or even a full stop and restart to recognize new assets. Let's trigger that now. Alright, assets should be ready to use now. Let's go back to our workout selection page.dart file. Find the body of the scaffold where we put that hello world text. Time to replace it. Delete the text within the center widget. Now let's add our ChoiceChip widget. You might remember the parameters it needs. We have to provide them. Let's give it an icon using the asset path. And give it the text label, maybe cardio. Let's set the isSelected property to true. And finally, for the onTap callback, let's just put in a print statement that says, I am being tapped. Looks like we have hit a snag. Even though the choice widget is visible on the screen and the tap functionality is working, we are seeing those I am being tapped messages in the console. Something's not quite right with the icon path. And it's being appended again within the ChoiceChip widget. Let's quickly fix this by just providing the icon file name directly. That should sort out the icon issue. Alright, that looks much better. Everything seems to be working perfectly now. But wait a second. Notice how the inkwell shadow is a sharp rectangle while our widget has those nice rounded corners. That rectangular shadow over the rounded shape. isn't the best user experience. Let's address that next. Let's improve this by heading back to our ChoiceChip widget and introducing a border radius to our inkwell. Observe the difference. Now that's a polished finish. Now let's have a quick look at when we assign is selected to false. Okay, but how do we make it change when we tap it? How does it become selected or deselected? This is where state comes into play, using our stateful widget. Up in the state class for workout selection page, let's declare a boolean variable. Maybe bool selected is equal to false to start. Now pass this selected variable into our ChoiceChip widget's isSelected parameter. This tells the chip whether it should look selected or not based on our page's state. Last piece of the puzzle, on tap callback. What should happen when we tap the chip? We give it a function. Inside the function, we need to toggle our isSelected variable. Flip it from true to false or false to true. And here's the magic. We must do this state change inside a call to setState. Calling setState tells Flutter, hey, something important changed. Rebuild the UI. That's what makes the chip visually update when tapped. Now we added the chip, created a state variable to track selection, passed it to the chip, and used setStep in the on tap to update it. Let's hit hot reload now and try tapping that chip. Yes, it should now change appearance with each tap. Our custom chip is not just a static element anymore, but a fully interactive part of our user interface. So tapping our one custom chip works perfectly. It changes state, looks great, but let's be real. A gym app needs more than one workout choice, right? We need a whole list: cardio, strength, fat loss, maybe more. How do we handle selecting multiple items from a list like that? We could try creating separate boolean variable for each single workout. You can see how that would get pretty bad really fast, especially if the list changes. There's a much cleaner way. Let's use a map to keep track of selection status for all workouts. Think of it like a dictionary. The key will be the workout name and the value will be a boolean indicating if it's selected. So up in our state class, instead of a single boolean, let's declare a map like this. And while we are at it, let's also set up a similar map to hold the paths to our icons for each workout. We can add as many workouts as we need, all starting as false. Okay, now we have our data structure holding all the workouts and their selected states. How do we display a chip for each one of these entries in our scaffold body? We can't just list them manually. We need a layout widget that can take up a bunch of children and arrange them nicely, maybe flowing onto the next line if there isn't enough space horizontally. The wrap widget is absolutely perfect for this. It handles that arrangement automatically. So back in our scaffold body, let's replace that single ChoiceChip widget we had with a wrap widget. But before that, let's add a column. We are setting the main axis alignment to space between, which will help us distribute the widgets vertically with maximum space in between. First up in our column is a text widget displaying the instruction, choose 2 or more to continue. Right after that, we will add a sized box with a height of 96 logical pixels. This will create a nice visual gap before we get to our next set of elements. We are placing a center widget to ensure its child is positioned in the middle. And the star of the show here is the wrap widget. Think of wrap as a row that automatically wraps its children to the next line when there's not enough horizontal space. Now for the exciting part, the children of this wrap. We are dynamically generating these using our workout selection map. So for each entry in our map, we return a ChoiceChip widget. For each workout, we are passing in the corresponding icon from our icons map, using the workout name as the key. The workout name itself becomes the text for the chip. Crucially, we are binding the isSelected property of the ChoiceChip widget directly to the boolean value in our workout selection map. When the ChoiceChip widget is tabbed, the on-tap callback is executed. Inside this callback, we need to change the selection status of the corresponding workout. We identify the correct workout using entry.key, which holds the name of the workout associated with the tabbed chip. So workout selection entry.key gives us the current boolean value for that specific workout in our map. Now let's look at the exclamation marks. The first one is the logical NOT operator. It simply inverts the boolean value. If the workout was true, it becomes false, and if it was false, it becomes true. The second exclamation mark at the very end is the null assertion operator. In Dart, you can access a value from a map using a key. The result could potentially be null if the key doesn't exist in the map. However, in our case, we are iterating through the existing entries of the workout selection map. We know for sure that entry.key will always be a valid key present in the map. Therefore, we are telling Dart, we are certain that workout selection entry.key will never be null here. This allows us to safely use the logical NOT operator on the boolean value without the compiler complaining about a potential null value. Okay, hot reload time. Wow, everything's at the bottom. Good news is, the tapping still works. Great. To fix bottom alignment and center our workout chips, we will use a spacer widget. It will grab all the extra space and push our chips right where we want them. Let's add that spacer in our code now. And we are centering all the chips horizontally with the wrap alignment.center. Plus, we have added a run spacing of 4 to give some vertical space between the rows of chips. But they still look a bit too close together. Let's jump back to our ChoiceChip widget and increase the internal padding from 2 to 8 units. Okay, hot reload time. Much better. That added padding gives our chips the breathing room they need. Looks exactly as we intended. Fantastic. All our workout chips are showing up, each with its own icon, and we can select and deselect them individually. That state management is working perfectly. So, the user makes their selections. What's next? They need to confirm or continue, right? We definitely need a button for that. Let's add a continue button. Now I have already got the code for this action button. It's pretty straightforward. Let's take a peek inside our widget. As you can see, it's a stateless widget, meaning its appearance doesn't change after it's built. Now let's talk about the parameters it accepts. First, we have onPressed. This is of type void callback, which is the function that gets executed when the button is tabbed. The question mark indicates it can be null, meaning you can have a button that doesn't do anything when pressed. Next, we have label, and this one's a required parameter. It's a string that determines the text displayed on the button itself. Finally, we have isEnabled, which is a bool and has a default value of true. This parameter controls whether the button is currently active and can be interacted with. If you set it to false, the button will typically appear visually disabled and won't respond to taps. Now that we know our action button is all about, let's hook it up to our widget and get it on screen. We are creating an instance of our action button widget. Let's go through each parameter we are providing. First, onPressed. We are setting this to an anonymous function. This means that when this button is tapped, the code inside these curly braces will be executed. In this case, it's simply printing the message, "I am being clicked." In real app, this is where you'd put the logic of what happens when the user wants to continue after selecting their workouts, maybe navigating to the next screen or processing their choices, or both. We have label continue. This is straightforward. We are setting up the text that will be displayed on the button to continue, clearly indicating the purpose to the user. Alright, we have got our continue button hooked up, but you are right. It's currently stretching and taking up entire width of the screen. To fix this, let's wrap our action button in a row widget. Then we will set up the main axis alignment of the row to main axis alignment.center. This will ensure our button sits nicely in the horizontal center. Now we can see that it's a bit too close to the bottom edge of the screen. To give it some breathing room, let's add a sized box with a height of 40 pixels. This will push the button up a bit and improve the visual spacing. We'll do a hot reload and button looks much better. The final touch to make this interaction bulletproof is to ensure our continue button is only enabled when the user has selected at least 2 workouts. To achieve this, first thing we are going to do is declare an integer variable at the top of our state class, and we will call it count. We will initialize it to 0. This variable will keep track of the number of workout chips that are currently selected. Now let's head back to our onTap function within our ChoiceChip widget. Inside the function, whenever a workout chip is tapped and its selection state changes, we need to update our count variable accordingly. So we will add a simple conditional check. This means that if a workout is being selected, we increment our count by 1. Conversely, if it's being deselected, we decrement the count by 1. Finally, let's revisit how we are using the isEnabled property of our action button. You can see here, isEnabled count is greater than 2. We are dynamically setting this based on the current value of our count variable. The button will be only enabled if the count is strictly greater than 2. If the user has selected 2 or fewer workouts, the count will not be greater than 2 and therefore isEnabled will be false, effectively disabling the continue button and preventing them from proceeding. This ensures that our app enforces the minimum selection requirement before allowing users to move forward. Hold on a second. My mistake there. The requirement is actually for the continue button to be enabled when the selected workout count is more than 1, not 2. Let's make a quick adjustment to our isEnabled condition. We will simply update it to isEnabled count greater than 1 instead of 2. And with that correction, we are now good to go. The continue button will correctly activate as soon as the user selects 2 or more workouts. Let's take a quick peek at our console output now. You will notice that I am being clicked. Print statement is indeed only showing up in the console when continue button is enabled. That is when we have selected 2 or more workout chips. And as expected, when the button is disabled, nothing is being printed on the console when we tap it. This confirms that our isEnabled logic is working perfectly. And there you have it. We did it. From clunky dropdown to smooth multi-select UI. We built custom chips, added smart button logic, step by step. Now this tutorial, we kept it simple, used set state. But the real project, it was more complex, naturally. We used block for state management, saved user choices, synced with a server. Real apps often need that deep structure. This project was an interesting challenge. But if you need help with your own Flutter project, feel free to email me directly. Let's discuss how I can assist. Thanks for coding along today and see you in the next one. Bye-bye.